acid-base review for the test on Wednesday. Let's take a look here and the kind of questions. Now, you have an outline exactly the same length of the test. So we're just to get some more practice ahead, right? So, acids and bases, conjugate pairs. Now, if I only looked at the left side, you might not know which one should be the acid. It'd be 50-50, because they both start with H, so that's not going to tell you. So I'm going to look from left to right. What is the job of an acid, though? It's to donate or accept a proton in H+. What is it? Acids, they give away or donate, or they accept. Oh boy. What do acids do? Do they donate? They don't. Okay. So what happens to the HS then, just because it's first? I know, take a look. It becomes H2S. That means it accepted an H+. That's obviously the base. HF, on the other hand, got rid of, it donated its H. This little H switched over to here, right? That's what happened. So I'm going to just change pens. And right underneath this, this will be my base. This will be my acid. And then HS negative, when it accepted the H, it became H2S. I'm going to put Cd for conjugate acid. Ca, I meant. Sorry, I said C. The base always becomes a conjugate acid. The acid, HF, becomes the conjugate base. If I read this, this is a double arrow, it's equilibrium. If I read this from right to left, take a look. Is this doing an acid's job from right to left? Yes. It is losing an H. It's donating the H to the fluorine. And it's the base, when we read it backwards, because it's acting as a base. It accepts from reverse direction. That's why it's called the conjugate base, conjugate acid. Read it backwards. Okay. Also, then something like this. We need to know these. Quick reaction, when this base, and I tell you it's base, is added to water. So it's going to do the job of a base, water. What is it going to do? And I'll give you a second. Tell me. Which is going to act? The water has to act as an acid. I didn't ask you to label it, but let's do this. It has to be the acid because this has to be the base. So, water. I like to think of water as HOH. I've told you that before. So I'm going to just put here HOH is how I'm actually thinking of it. It loses the front H, then makes it simpler, and hydroxide's left behind. Okay, so write down what you think you get. Let's check each other. I'll give you guys a few seconds. Okay, you guys are ready. What does the base ClO negative become? And there's no charge on it. And that's important because I'm looking for charges on it. And this is hydroxide. Okay. If I required you, which I do generally, to put aqueous, liquid, everything else is aqueous other than water. That could just be assumed. Now, the reason why that's important is if you have to come up with an equilibrium expression, the water, because it's a liquid, it's not aqueous, does not appear in the expression, right? Or in an ice chart equilibrium. Now, this is pretty straightforward. I just want you to use your calculator to do these with proper units. As a reminder, I'll ding you, right? You don't have the M's in there. So, you've got your formula sheet. 10 to the negative pH, 10 to the negative POH, or else the negative log of H2O positive or negative log of OH negative. And then pH and POH add to 14. Those are the formulas. You don't have to memorize them, but those are what you're using. Cool. Time to rip into them. So, pH and POH, they have a difference of 14. So I think this POH blank 14 minus 10.3, I got 3.7. And it's disappearing ink, so I'm going to change it. Oh, let's go with green, something different. Okay, I have pH and I want H3O. So I go 10 to the negative pH, 10 to the negative 10.3. Flip around and I get 5.0 times 10 to the minus 11. I need the unit for the full mark. Did you grab the sheet or do you have it? Then, for the hydroxide, I use my POH, 10 to the negative 3.7. That's the second function of the log bar. 2.0 times 10 to the minus 4. There we go. Now, there's a couple of ways we can attack the other problem. This one we went left to right, but we don't have to go in any particular order here. What did you guys suggest to do first? I'll follow you guys. pH? Okay. Use the negative log of decimal 0.27. You got 1.57? Yeah. What was it after? You guys said 1.56. Hang on. 1.6. Oh, you put 1.6? 1.57. I'm going to put that down there. I can't remember. I thought you said 1.5. 1.6 is 5. Now, I'm thinking, I'm just going to do it on a calculator and see. I think you need to do proper rounding, but I may have made a mistake. So I'm going to go negative log, my calculator, of 0.027. I get 1.568. That means I need to round it up. We're going to do it on the phone. Log stuff. You can put 1.6. That's proper rounding. 1.56 is not. You should actually keep 2 spots. Incidental. Significant digit-wise, and I'm not marking for significant digits, but since there's 2 significant digits here, with a log, the front number actually represents the power, 10 to the negative 1-ish. And then these are actually considered the significant digits in the log. That's why I use 2 decimals. Incidental. Okay. So, for the other one, 14 minus 1.57, or in Faith's case, 1.6, you get 12.4 in Faith's case, or else 12.43, you get 12.44. That's it. But you do need to do proper round. So, 12.43. Now, because there's a little bit of difference between people, I accept a range of answers, but I got the 10 to the negative POH, depending on your value, 3.7, 10 to the minus 13. That's a really crappy 13, so I'm going to redo it. And I need the unit. By the way, that's not the only way you could have done it. You could have taken this value and went, and, oh, right, I can't do it. And you might have gotten a slightly different way. Or, I'm going to just say here, you could have went 1 times 10 to the minus 14 divided by 0.027. If you did that, you might have gotten a slightly different thing, because there's some rounding involved. And then that would give you an answer very close to that. Yeah, because you had different rounding. You had 12 points. Totally, I would accept it. Okay. Now, the second page I printed really is just other years. If we needed more practice with this, we'd make up questions. I'm thinking right now, we'll see about it. So, I'm going to ask you guys to do this page. Okay? So give the equation when HA is added to water. This, HA, just a generic acid, plus water. You need to put these liquid proper charges on the other side. Now, you guys start this problem. This is what I'm talking about. Go for it. Okay, we'll take this one out. Make sure we're on track with these kind of problems. So, when you add an acid to water, the acid's job is to donate. So the HA becomes A negative. The water accepts it's acting as the base. So it becomes the hydronium ion. Okay? That's that. Now, I'm going to use that equation above as my ice chart hints. I'm going to put ICE. I know that water, being a pure liquid, won't have any entries. Okay. So we start with the HA is a weak acid. 0.35 initially. We don't have anything else. We'll assume that it was just dropped into the beaker. We'll use zeros at the start. So the right-hand side can only go up. That means the left-hand side has to go down. We don't have numbers for the end, so we're going to use X. And we have an expression for the equilibrium concentration of the HA. 0.35. Okay. This is what I'm looking for. That's what we do. Write the equilibrium expression, the K expression, KAE. That's products over reactants. You never include a pure liquid. KA, products, A minus. I'm looking for the charges. So that's my expression. Find my H to go. Well, you have the formula sheet with you. We are going to take a shortcut. Remember that if you can assume that this is a small value, we will. I won't give you one that you can't assume. Okay? So we're going to assume small value, even if it isn't a totally valid assumption, it might be out by a couple percent. We're going to make that assumption. So that means that we've got H3O positive, this is the formula I'm using, the square root of the Ka and the acid concentration. Okay. So I plug my stuff into here, and this one's not hard for manipulation. Oh, switching. So I have the Ka from above. 2.2 times 10 to the minus 4. Multiplied by the concentration of the acid, 0.35. And I come up with 0.11. Good. Find the hydroxide. Well, from this, I would suggest a couple ways to do it, but here's the one is hydroxide concentration. If you have the hydronium ion concentration, it's 10 to the minus 14 divided by the other concentration. give me 9 point minus 15. Another way you could have done that was find the pH, subtract from 14 to find the pOH, and then 10 to find. You'd probably get a slightly different value. Oh, I wouldn't get full marks unless I put. Okay. Last page. Some people would work ahead on it. Take a look. Titration problem. So if you were given experimental data, you have 20 mLs of nitric acid in a beaker. You add, which is going to be a red, so you titrate, the concentration of the base 0.1000 solution of hydroxide, potassium hydroxide. So this is the concentration of the base. This is the volume of the acid. 3 trials are performed, and you got 3 different volumes, so you need to find the average volume. So I'm going to call this the volume of the base. You know how to do an average. You add 43.5 plus 42.24, 42.25, add them up, divide by 3, and go for it. Then you're going to write out that neutralization reaction and use the titration formula to solve the problem. I'll give you a few minutes here. With proper rounding, what is our average of the base? I know it's 43. Okay, milliliters. Okay, 0.33 milliliters. Then, a neutralization reaction. If you didn't know what nitric acid was, you have a sheet with all the acids listed on it, the KH sheet, but HNO3. I gave you that it's potassium hydroxide, so that's the base. When you add an acid to base, it's really messy, so I'll rewrite it. You get a salt and water. The salt is when you switch the K plus with the H plus, you get KNO3. And water, I'm going to write the water as HOH. I look at this and it's already balanced, ones all across. So find the concentration of the nitric acid. I would use the titration formula. Balance of the base is 1. So I'm going to just write that in there, but you don't need to. It's not mathematically changing it. Concentration of the acid is what we're trying to find. I think with 20 mils, the volume of the acid. Balance of the acid is 1. Concentration of the base, I think I decimal one. A lot of zeros. The volume of the base is 43.33. Now it's just arithmetic divided by 20. Okay, so Ca, since I know what the acid is, I'm going to list that in the answer. 0. I have 4 significant digits in everything, so my answer will be 2.167. The unit is moles per liter, and I've got a list somewhere. I have to somehow tell me, you guys got to tell me that this is the acid. Okay. That's that. We are done our review. You guys should be well prepared.